You may not have recognized them so far, but they are out there in the code, somewhere hidden, waiting. In the C programming language, underline T data types seem to be everywhere. Yeah, and the fact that they are so omnipresent in C source code makes them a perfect topic to talk about them. And with that, welcome to my C talkthrough. So, if you start writing code with the C programming language, they may catch your attention when you have a look at some libraries. Identifiers with a trailing T, like time underline T, size underline T, and other kinds of underline T data types, usually specific to some function or library. The C gurus have a method with their madness when it comes to naming those kind of things, and underline T is not an exception for that. It stands for something, and that is very consistent on purpose. It has to do with, distinction. The distinction from in C programming language built in, or let's call them basic types, and to something else. Yeah, but first let's have a look at the in C available basic types. We have char for character. It also includes strings as array of type character. There are int for integers, so whole numbers. By default they are signed numbers. We have float as a type for floating point numbers, and we have a double that's also for a float, but with a higher precision for the fracture part. So, and for all that basic types, we have qualifiers, which can be applied to basic types like short, long, signed, unsigned. I guess you already know that this means that you can apply a qualifier like unsigned to a basic type, and that's, if for example here in this example we use the qualifier unsigned to an int and assign a value of 23 to the identifier x. And in this example, the most left zero in the binary notation of this number now means nothing else that it extends the range into the positive, which is not interpreted as a sign, but as to the power of 2. So it is nothing else but saying I have the same amount of values here, but I want them to be interpreted as only positive values, and I use the very left bit here to extend the range to the double. Yeah, despite data types like void or underline bool are available, only these 4 basic ones plus a few of the qualifiers are used for that underline T data types naming. The crucial question is, or the crucial questions are, is there a secret in that? Is it some kind of conspiracy about going on? And most of it all, why bother and who cares? The main reason for the usage of underline T identifiers for data types is compatibility and consistency between architectures. And that is something nearly every C programmer should keep an eye on. The whole thing is not so much about system programming, but with the C programming language itself, because it is for practically every operation system available, to today, and the interoperability amongst several on C dependent operating systems makes nearly all C code appear like written ones used often. So does naming types with underline T have something to do with compiling then? The answer is surprisingly no, not at all. Compilers don't care about underline T notations. Underline T naming can feel much more sure about its meaning than we as humans do. It does not need philosophers nor Douglas Adams to ask and answer the ultimate question about life, the universe, and everything. The answer which justifies their existence is as simple as reasonable. Here it comes. To add trailing underline T to the identifier of a data type implies a type definition with the keyword typedef, hence a defined data type. The typedef is based on an already existing type. Boom, microphone drop. So easy programming can be. Underline T is a human convention so that the video could be over here. But it is important to remember this convention when hacking in your code on your keyboard. For example, it is a crank idea to let an identifier of one of your functions or something end on underline T. That will for sure lead to confusion. At least the same important is that on a POSIX related system, many to all underline T data types are reserved. If you use your own underline T data types with typedef, you should do only so if you know what you are doing and if it is intended to work with exactly that reserved type. A useful workaround in that case that you run-of-the-mill programmer want to prepare your own data type with typedef and you want to distinguish your identifiers for your own data types from those of variables, you can use a different name convention like, for example, a trailing underline type. So underline TYPE, for example. Yeah, some side notes you should be aware of is that, for example, all identifiers ending with underline T are reserved for future additional types. The whole int32 underline T family of types was added in the C99 standard. So they use the reserved names to avoid conflicts with already existing software. You can find an overview of reserved names in the glibc documentation. Here you can see reserved names and also you get aware of that names that end with underline T are reserved for additional type names. So also if you have here a look at time.h at the header files, you can see that there's a lot of stuff already prepared. And there you can also find several data types ending on underline T. Clock underline T, time underline T, and that are typical some to have a quick look at. For example, here at time underline T is a reference, and in Unix and POSIX compliant systems implement time underline T as an integer or real float type, typically 32-64-bit integer, and which represents the number of seconds since the start of the Unix epoch. So since January 1st, 1970, Unix systems are counting the seconds of the ongoing time, and from that, let's call it absolute time, you can calculate nearly every date or whatever you need independently in your own functions. And here you have also some little code snippet for C, which we will have a closer look at. So I will just copy paste that in here and we have a quick look at. As you see, it's nothing really special here. The result should look like something like this. So outputted will be the actual date and day of the week and so on. And we have a quick look and let it run. So as you see here, it works totally fine. It tells me that today is Friday, 2022, November the 25th. Here's the time of the date as in the time zone or interpreted as CST. And that is exactly what we expected to see here. It does nothing else but use time underline T and define a now for that. We get the current time just by using the function time null and assign that value to our now. And from that, we want to produce some string, and that is local time for exactly now. And that string now, we interpret it. We need to interpret it, that string, and for that we have a string format time as a function, which outputs us a human readable string into buff, which is defined at a specific size we want to write it in, and here we have some identifiers, here we have some placeholders, and our time string will be just then outputted into buff, and then we output buff. So what exactly happens here is that, for example, at this point here, we do nothing else but we convert the seconds since the Unix epoch started into a broken down time expressed as local time, considering time zone, seasonal adjustments, and so on. So what we are here doing is nothing else but first getting the epoch. What we are ongoing doing then is that we interpreted that number, it's generally nothing else but a big integer, as a string, and from that string we use the string format time to interpret that number. So you saw that that worked totally fine, but I want also to have a look here into the header file time.h, and I open that here, and as you see, it what is it, 500 lines, 442, and within here I will search for time underline t, and here you see it is also included. So it loads from bits / bytes / time underline t dot h, and also that I want to open here, and within here underline t is defined. Now it seems I opened the wrong one here. what I wanted to open was not struct. It was time underline t dot h. So this is the right one. And here you see time underline t is here used. Is a double underscore here, you see? That is a double underscore. If you ever ask yourself why you stumble over such a naming convention, please note that the underscores here are used to distinguish names reserved for the implementation of the concrete function or library from names that the user's source code may implement this library can use. Users can do define foo1, but they must not do define underline foo underline 1. And therefore the implementation is free to use the names the name underline foo underline for its own macros, variables, functions, and so on. Rule of thumb is don't name your identifiers with preceding underscores unless you exactly know what you are doing. So back to our time underline t. And no matter how a library or operating system measures the time, in C you can use the time underline t data type to declare a time value. And years ago, this value may have been a 16-bit integer. Then it became a 32-bit integer to deal with the year 2K problem. Yeah, you may be too young for this, but when the year 2000 came, it was expected that old hardware running outdated software with only namespace in memory for 2 digits to keep the year would fail all nuclear power plants, clocks for public transportation would stop, and all elevators would become inaccessible, and airplanes drop from the sky like a massive metal hailstorm, and eventually that would lead to the collapse of the modern civilization. Yeah, well, it came not that bad, but for the year 2036 and 2038, we might again run into trouble, because it might be that some 60-bit for integer types on some systems run out of bits to store interpretable values. So still, no matter what the underlying mechanics is, your code compiles and provides you the option to use the time underline t data types when dealing with time values. And the underline t part only gives you a clue. Hey, that's here a data type made with typedef, and it's for me to be used. Thanks for that, and here we go. The question what underlying type is used does play a role when using a placeholder though. See here, for example, the size of operator returns a size underline t value, essentially a number of bytes. Often I use the percent %d. I copy that in here now. Often I use %d to output that. Here I will add that printf, and now I just will output buff is of that number of bytes in size, and then I use here size of buff. So that worked for years totally fine. I will let it run now, and at the same time we have a look here at the build log. So actually it does not run at all because I accidentally added a W here. So, but also no, that should be TS W. No, I messed up worse. It's time underline T, and I hope that the code will run now. So here it runs as expected, and also my line appears here. Buff is of 80 bytes in size, but if we have a closer look at the code itself, we can see here as a build message this line. And this line says there's a warning that %d expects an argument of type int, but argument 2 has type long unsigned int. So what does it mean? It means that meanwhile the time underline t, or respectively here my buffer thing, is of the wrong type, and if I use to output a decimal for that, for buff, then it just does not work, because the number of bytes meanwhile changed. So meanwhile it is a long unsigned, so WU should be the right placeholder here. And after compiling, my program works totally fine, or still works totally fine. But here in the build log and in the build messages, I have no more errors or warnings anymore. Years ago, the %d placeholder worked totally fine, but the underlying format is unsigned long now. And GCC, and I guess so does Clang, is nice enough to show me where I used an outdated placeholder, which argument is referenced, and which conversion characters to use. It's all too often that I rely upon the compiler warnings, like to discover which placeholder to use. At least for me, the compiler always knows better. Of course, that's also true if I want to output TS here. Then I have to check what kind of type it is, and in this case here, TS is of type long double. And if I output that, you see it's a really big number. And yeah, by the way, the ZU placeholder can always be used to output a size underline t value, whether it is changed in the future or not. We will quickly try that here with, yeah, let's try that here. And you see, I can output now here with U for an unsigned. I can output it with LD for a long decimal, but ZU for sure works totally fine. LD gives me here a long int as a problem, but that's probably somewhere else. It's here for local time. ZU should always work totally fine. So ZU expects type size underline t, but we have here a struct tm. So here we cannot use it. Where we can use it should be here. So on line 26, here a long int is expected, but, or we want to output a long int, but the argument has type struct tm. So it should not be output this way here, but you can at least try it. Yeah, when you don't know the underlying data type for underline t type definition with typedef, you can go hanging out sometime in the header files to meet the specific definition. Sometimes you might be lucky and find the typedef immediately in the header file. With modern libraries, however, the typedef is most likely included in another header file, often in a subdirectory. Finding it may be a time-consuming operation. Remember, time underline t header file we found in bits types, and time underline t dot h, but that file was included in the include bits time dot h, and where its definition is related to define constants in even other header files. In other distributions with other organizations or other organization of the source code, or in header files, or with other C compilers, or other operating systems, or even other C variants and versions, it might be different. It's hard to dig yourself through something like this sometimes. So if I wasn't afraid of an army of lawyers eating me alive for breakfast, I would sing a few lines of the Beatles song Let It Be, Let It Be, but it is best to just use typedef names as intended and stick to the words of Tony Soprano. Period. End of discussion. What you learned in this video is that in the C programming language, underline T hanging to an identifier indicates that this is an identifier for a data type which was set up with typedef and is available after including a header file. And as a last takeaway, also from this episode of my C Talkthroughs, if you face an underline T type and the main page does not explain which placeholder to use for a formatted output, remember you can best guess it and wait for your old friend the compiler spitting out a warning which revealed the right type to use. This approach may be the short run some frustrating, but it works.